All right. Unfreeze. There we go. Did you guys all get your assignments turned in? Easy peasy, lemon squeezy. So I did notice this, so I had to email a couple people. You know how like the lesson plan, like if you pull it up on your computer, it gives it to you for the whole week. Well, Sunday is the new week, so it flipped you guys all over to like this week for the assignment. So the students clicked on the attendance form for this week, and we're submitting assignments for last week, right? So just make sure, like, if you ever run into that little situation that when you're submitting the attendant or the assignment, like I put the date like up in the title, and then just make sure like that assignment matches, just so you make sure it's on to the right week. But then I got smart too, and it's like right now I like turned off the submission for this week, so I have to remember to turn it on when I get done with you guys today. Sound good? Yeah. Alrighty. And hopefully we'll have everything figured out, and Go Guardians get all their bugs worked out, and then on Monday we can take a quiz. So a week from today we'll take a little quiz over what we learned this week. Does that sound exciting? Woo! There. Alrighty. So we're going to move on to the next little section, our little P2 section. And P2 has to do with exponents. Do we all remember what exponents are? Those little doohickey thingies up above the little thingy, right? All right. So let's go through some properties of exponents and see if any of these come back to us or if they're all new. So the first one we're going to go over is called the negative exponent rule. So this would be if our exponent was negative. So the little formula would be like if you had some base b and it was raised to the negative exponent, you can technically rewrite this. That negative makes it the reciprocal, so it flips. So this would become 1 over b to the n. If it was written as like 1 over b to the negative n, so on this one you still have to do the reciprocal, so it's going to flip it. So what do you think it's going to equal? B to the n. So let's say we had 5 to the negative 3. Can we simplify that? Because we don't want to have negative exponents. We want to make sure that at the end of our day that our exponents are all positive. So how would we rewrite that? 1 over 5 raised to the third. And then we can actually find out what that is, right? So that would be 1 over, what's 5 to the third? 125? Yep. What if I had 1 over 4 to the negative 2? Can I rewrite that? Would that become 4 squared? Which would be 16? Yeah. You guys good with that one? Right? Not too shabby. All right. Ready for a new rule? Today is full of rules, all right? The zero exponent rule. So this would be if you had some base and it was raised to the 0 degree or the 0 power. Anybody know what if it's raised to the 0 it's going to be? It's a big number. 1. Yep, it's always going to be 1. So if we had 7 raised to the 0 power, that would be 1. Yep. What if we had -5 raised to the 0? What's that going to equal? 1. What if I wrote it as -5 raised to the 0? What's that going to equal? This one's tricky. This one's actually going to be -1. Okay? Because what's on this one, what are you raising to the 0 exponent? You're just raising the 5 to it. So the 5 to the 0 is going to give you 1, but you still got the negative on the outside. Okay? Where on this one, what are you raising to the 0 degree? The whole entire piece, right? Yes. So, like on this one, because you have that -5 raised to the 0, this whole entire piece is being raised to the 0. This one is the same thing as like -1 times 5 to the 0. So the only thing that you're raising to the 0 power is the 5, because that negative's on the outside. It's just like when we would square certain numbers. Like if you wrote it as -2 squared or -2 squared. So on this one, the whole entire thing's being squared, so that's going to be 4. On this one, the only thing that you're squaring is the 2. So you'd have negative and then 2 squared, which is 4. It's just the difference in the way you write them. Because this is the same thing as like -1 times 2 squared. Does that make sense? Yeah. All right. Ready for a couple more properties? So the third property we need to talk about today is the product property. What's product mean in math? Multiplication. So let's say we had some base, b, right? And it was raised to the mth powers, and we had a number to the same base raised to n. If we want to figure out by combining that, that's going to be like b times n plus n. So let's say we had 2 to the 3rd times 2 squared. That's going to give us 2 to the 5th, right? So sometimes when we're working on these problems, we forget that property. So if anything, this 2 to the 3rd, this is 2 times 2 times 2, right? 2 squared is 2 times 2. So that would be 2 to how many's? 1, 2, 3, 4, 5 to the 5th, right? So if you get confused and you can't remember if you're supposed to add those or multiply them, just write down like a simple one, you know, and kind of like on the 2's like this one, and then be able to count them and be like, oh yeah, that's right, I'm supposed to add these. Does that work? What if we had 2 to the negative 3 times 2 to the 7th. What do you think that one's going to give us? Two to the, what are we going to do with our exponents? Add them. So we're going to get 4. And if we wanted to write this one out, like the nice long way, that 2 to the negative 3, is that the same thing as 1 over 2 to the 3rd, right? And then we still have 2 to the 7th. So that would be like 2 to the 7th over 2 to the 3rd, right? And if we were to write this out nice and long, that would be 1, 2, 3, 4, 5, 6, 7. All over 2 times 2 times 2. Then what can we do? And how many do we have left? 2 to the 4th. You guys look like you're highly impressed with all of this today. All right. Let's try the quotient rule. So the quotient rule is just the opposite of the product rule. Product means multiply, quotient means divide. So if we had some number raised to a base, or sorry, a base raised to an exponent, and we had that same base raised to another exponent, if you multiply, you add them. If you divide, you subtract them. So this would be the same thing as b to the m minus n, which is actually what we did over here, right? So let's say we had 2 to the 8th over 2 to the 4th. That's going to give us 2 to the 8 minus 4. And it's always going to be top minus bottom, which is going to give us 2 to the 4th. Anybody know what 2 to the 4th is? 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. And again, like on this one, if you can't quite remember, you can write these out with the fraction, right? 2 to the 8, 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. What are you left with? 2 to the 4th, which is 16. Yeah? All right. One last one. How's that? So the fifth and last one for today is called the power rule. So on the power rule, we got some base raised to an exponent, and then that whole entire thing is raised to an exponent. So on these ones, you just multiply the two together. So let's say we had 2 to the 2 squared, and all of that was to the 3rd power. So that's going to give us 2 to the 6th. Okay. And then if you can't remember which way the rule goes, if you're adding or multiplying, then write it all out.
because this is ultimately saying this is 2 squared. And how many 2 squareds are you going to have? You're going to have 3 of them, right? So that would be 2 squared times 2 squared times 2 squared. Whoops, that's a square. Right? That's that 2 squared to the third. And then 2 squared would be 2 times 2. Right? This squared would be 2 times 2. This squared would be 2 times 2. So we'd have 2 to how many? 6. Right? Anybody know what 2 to the 6th is? 64? I'll go for that. And then these ones can get even a little fancier. Like sometimes instead of just having one base in the parentheses, you could have like AB all raised to the nth degree. So you got to multiply that n. So that n has to go to the A, and that n has to go to the B. So this would be like A to the nth, B to the nth. So let's say we had, I don't know, negative 2y raised to the 4th. So what are we going to do with our 4th? We got to take it to everything. Okay. So you got negative 2 raised to the 4th and y to the 4th. Is that 16y to the 4th? Excited to try some of these. See if we can hammer them out. Okay. I think doing these kind of problems make you feel smart because like sometimes they get all weird and crazy and you're like, what? Then you just kind of like take a deep breath and you're like, okay, I can do this, you know, do this piece or this piece. Then you bust it out and everything looks good. So for today, we just got some little even problems to work on. All right, on page 28, 2 to 38 even. Not too bad. All right. You guys got any questions? Think you're good? Okay. How about my onliners? You guys doing all right?